So we got Java, we got Grails, we got some Node, and we got a couple of Ruby monoliths, and we're splitting them apart into microservices. So that's an opportunity to maybe use Elixir. So we've been doing some Elixir prototypes. And so this is a first draft of one of the microservices we've been putting testing out to build in Phoenix. There's a lot of jargon, there's a lot of products in this space at the moment. It's a little bit bewildering. I'm still a little bit lost. And anyone correct me if I'm wrong, but as I understand it, Kubernetes gives you an ability to have infrastructure clusters. So it has load balancers, replica sets, allows you to configure ports and load balancers and all of that sort of stuff. There are other alternatives. So if you are not using Kubernetes, you can use Amazon's ECR out of the box. It's fairly limited. It's all a matter of how much do you need to do. With us, the decision to use Kubernetes was largely decided by our ops team because they said, no, we need to be able to spin up extra clusters in the middle of the night when some goes down. They have a whole stack of reasons. They evaluated Kubernetes, Terraform, and ECR, and they said, ECR, it's a tiny little subset of what we need. Kubernetes does everything we need. Terraform, it kind of intersects with Kubernetes. So Terraform is a scripting language for cloud infrastructure.
It's basically infrastructure using software.
Yep. And you can do the same sorts of things you can in Kubernetes with Terraform. There is some overlap between them. Once again, this decision was made sort of outside of my expertise level, so I'm just going along with it. Yeah.
Yeah, they're kind of. I can see why you say that, but you can use them both very happily together.
And we are.
Yeah.
Right. So that's what we're doing. I mean, largely, we have the cluster set up with Kubernetes, and we use Terraform scripts to manipulate most of them, and some Kubernetes scripts to do the rest. We've got everything on AWS in EC2 container service. We're running BuildKite, which is, we were using Travis. Travis is, yeah, look, so it's okay. It's just a bit slow and it's a little inflexible and it's actually quite expensive. We were spending $1,000 a month on Travis, and it's like we were waiting 40 minutes for our test suite. Admittedly, that's because our test suite is crap. But we've changed that now. So with BuildKite, that's given us the ability to use our own AWS instances. So we don't have to, go cap in hand to Travis and say, "Can we have some more instances, please?" And they went, "Sure, give us more money." So we've got all these AWS instances. We spin up as many as we feel we need, and because we can run stuff in parallel, we've split our tests up so that certain ones that can run in parallel do, and so instead of taking 40 minutes, it's now taking 7 minutes. And so that's great. BuildKite also helps us a lot because it's our own infrastructure, it frees up a lot of constraints for PCI compliance, and we do a lot of credit card processing and what have you, and so that's really helps us a lot. We use BuildKite to run our tests, but we also use it to build the container images and deploy them, and then not to deploy them, to push them to container repository, and then we use Terraform for the final deploy. So, this is not optimized at all. This is my first draft in conjunction with some guys from the ops team holding my hand, going, there, it's not that bad. So, here's where we started. We had a Docker file, pulling down from a basic Elixir 1.4.2 image, installing some Postgres, some basic libraries installed, putting rebar and hex, setting some locales, and then basically ending up with mixed depsget. And that builds our base Docker container image. And I didn't name this right. This one is actually our production release one. So, same sort of thing as before, except what we do is we get down to the bottom and we take the built gzip that we've built in the outside world, and we put it there and unzip it.
Setting the time zone.
Yeah, I don't know. I think I copied and pasted too much. I copied and pasted too much there, I think. In our BuildKite pipeline, our BuildKite pipeline is really pretty straightforward. It's just got 2 steps in it. One's to build and one's to release. The build script runs our test suite. You get to have some nice little, these bits here, you can put these things in here and you get a nice little Elixir logo. It's very cute. And then, you know, assuming everything goes great, you get a green light on your BuildKite pipeline. And if we just go ahead to our release script, what our release script has done after it's run all the tests, does some basic Dockery stuff, and then pushes an image up to the Amazon container. There's some clever stuff you can do here where you can speed things up. So for instance, the next thing that I'm going to do is like running deps get and building all of the deps is probably the slowest part of this step. So there's some clever stuff where you can push an interim layer. And so if that hasn't changed, you know, you take a shower of it, the next time you run that script, if nothing's changed, you get it, you know, instead of taking 3 minutes to run, it'll only take like, you know, 1 second. So now we're getting into our Terraform scripts. So this app's just called Sandbox. It's a test of our payment gateway microservice that we were going to be doing. This is basically a lot of boilerplate stuff that, you know, for any sort of deployment is going to have it, but the main guts of it is here. Things I haven't figured out how to do yet. This thing on the end is my build number. I need to figure out how to get BuildKite to do that automatically. Haven't figured that out yet because I'm dim. It probably involves tags. We set up some database stuff which comes from some config files from Terraform, which I'll show you in a sec, and setting up a secret keybase, etc. So this is just basically setting up secrets. The way we're doing it here is not the recommended way of doing it. Ideally, we would use a service like Kubernetes, KMS, or Vault, which is a secure secret storage system. Okay, this is another config that you run, which just connects the outside port onto port 80 into the port in mix phoenix.server. Now deployment time, and I'm going to do it live. No, because today I found a bug in Kubernetes 1.5 and it's got a memory leak and everything that I prepared for today is broken. However, I do have another one which I prepared last week which still works. So I can show you that one. But roughly the steps to do the final deployment, we log into the Kubernetes dashboard. We make sure we get a namespace. You don't have to have a namespace, you can work in the default namespace, but the more deployments you have, you want to make a namespace. It's just a matter of specifying a YML file, this, and running this command. You now have a namespace, stuff goes under there. We set up our environment variables. So this is where we set up the database URL and the secret config for Phoenix. Just makes another YML file in the Kubernetes dashboard. And then we say, okay, deploy the service and connect up port 80 to port 4000. So what I can show you is, and I was already there, all right, so this is our Amazon container repositories. So these are all the builds that have happened on, as I was saying, the Sandbox app, which would have liked to have shown you, isn't working, but this is one I was working on yesterday. These are all the builds that BuildKite has produced and then pushed a container image up there. This is a cluster which our ops team put together, which is running the whole Kubernetes dashboard. And this is the Kubernetes dashboard. So if we go here, we've got a bunch of namespaces. These are all the different sort of projects that we're working on. Sandbox, this is the project that we want to look at. And as you can see, stuff broke. So I'll go back here and we'll look at the TBB. And we're already logged into that. So we have a look at the last deployment. So this is a deployment in PayX. Look in here. It's got a replica set. It's got an endpoint over here. So we'll have a look in there. There's only one node attached to this, or pod. Sorry, I'm still getting used to the jargon. Which is a Kubernetes item here. We can have a look in the logs and see that, yep, it ran stuff, did some bad stuff. I don't know why that's working at all. Sorry, I'll just go back here. That's that deployment. And if we have a look at this and look at the endpoint, yep. And this is a sample page, very similar to the one I was going to just show on the Phoenix app. So, and that's it. So that's what you have to do. This is our BuildKite configuration. BuildKite is awesome. So this is it as it runs along on these things. The main guts of what happens in here is it runs the build, installs this sort of stuff, then runs mixed deps get, goes and gets all the deps, compiles them.
So does it do everything in a Docker container?
Yeah, it saves the Docker container image. Then the very last thing it does is upload it to, let me have a look at that down here.
Is the image building conditional on your tests passing?
Yeah, it is. So we've got a very simplistic set of steps at the moment where it just goes do this, and if it doesn't fail, then do the release. But we will be adding quite a bit of complexity to that, like I say, for the caching of the layers. So if the dependencies haven't changed, fine. If the build hasn't changed, fine. There's also some other stuff with static assets and that we'll be putting changes for that in. Yep. So optimizations and improvements that I need to do on this next. Caching the dependencies. There's a couple of different ways of doing that. One, you could create another container image layer and push that. That's a little complex. I haven't quite figured out how to do it, but the quick and dirty way of doing it is you tar up the deps and the build directories, put a SHA on them, and shove it up on S3. It is quick and dirty, but given that it's all running on Amazon, transferring things to and from S3 is fairly quick. Fixing the thing with the build number, that would be good to do, because at the moment I currently have to change it manually. And then the next step is putting a deployment hook on GitHub, so that we just do a PR into a particular branch and say, okay, then just automatically deploy that. And that would be great for our UAT testing. Currently we've got a convoluted process of releasing our servers, and we've always got our testing people saying to us, have you deployed it to that server? Well, no, that one's busy, can you deploy it to that one? And it would just be good to just say, okay, build, deploy to whichever one you want, and it's done.
BuildKite supply that, because when you create one of these releases, or when you're creating, I can't remember what they're called, when you're doing for one repo,
yep.
it says just go and paste this into GitHub, and click pull request to deploy or whatever, and it automatically just runs whenever any of those conditions.
Yeah, so I mean, BuildKite's got stuff automatically in for that, where you can say, okay, on a pull request that gets merged on a particular branch, I run this script, which is great. I just, once again, it's just a matter of time to do it. And what the way we plan on doing it is we'll have a branch for the different test environments that we want, because we've got one for third-party integration, one for the internal testers, and one for our clients that want to see beta versions of it. And so we'll just do a PR into those branches and then automatically deploy. Cool. So that's what I've done. It's been painful, but it's getting less painful.
How long did it take to get it all going?
Took about a week after having a couple of intensive sessions with some people that knew what they were talking about. And so I'm still not feeling 100% confident on it all.
We've got Terraform and Kubernetes.
Yeah, and it's like any of those things, like Puppet and Chef. You know, you could spend your whole career just doing those things, you know. So you just got to pick and choose your battles. And
What's the overhead of running Kubernetes? Like, what's the base amount of runtime instances you have to just support Kubernetes itself?
just like a fairly small AWS instance, as far as I know, to run the dashboard. And then, you run the management node as, you can potentially run all of it on one, AWS instance, but that would be mad. And generally what people do is they just have a management node, which is just the bare minimum you can get away with. And I think it can be like a small or T2 instance. It's not a lot.
Down fairly small.
Yeah.
You only have to use a certain subsystem.net, but it can go.
Yeah.
Way like
Yeah, and that's that one. That's another reason. It's not the only reason that we chose it, but yeah, that was one of the reasons, because
it still takes months and months to set up.
Yeah,
It's
plus if you have
it's a
three
big.
instances of Cloud Foundry, what's the difference if you're going to deploy hundreds of containers?
Sure,
for itself,
but it's not very interesting like put it all quick when you're small.
Okay.
yeah, exactly.
All your baseline AWS costs hundreds of thousands of dollars a month before you've got partners.
Somewhat related to that, one of the interesting things that's come out of this is, what's the best way to do things? So that one of the sort of chicken and the egg problems you often have with containerization is, ideally you don't open up every bloody port on your container and then SSH into them and twiddle on them. You can do that, but you're kind of mad because you open yourself up with security problems. So, when talking with the ops people, say, well, what do we do about that? Well, let's say you want to run rake db migrate on a Ruby, a Ruby server. You can do it the really dirty way, where you can just change your database URL locally and just point to it and make your database public, which that's bad, right? Yeah. But generally the other way that we've been doing things is that we just spin up a temporary management node that just has permissions to SSH from us and connect to that machine. And we just create it on the fly, run the task, and then, Kubernetes just shuts it down afterwards. And you can script all of that. So, you start it up, do your stuff, I'm done, close it down. You do need to use Vault. So, we're tossing up between Vault and KMS for that. So Vault and KMS are basically encryption as a storage, plus some extra features. And we don't know which one we're going to use yet. KMS is good because it's built into Kubernetes. Vault is good because it's built by HashiCorp, which wrote Terraform. So it's like, why can't you all just get along,
We do something pretty similar. We don't use Kubernetes for a homegrown system, but use Terraform and BuildKite for building images for pretty much every PR and just about every push to every PR. And one of the big things we get from that is the ability to then deploy those pretty easily. So when you develop it and then just deploy that, there's some infrastructure set up for DBs and the like, but you can then pretty much deploy any commit and show it to internal or external people. So it's really nice within sort of a couple of minutes having something up and running that you can show and get tested and the like. That's one of the big
That's our goal. That's what we don't have at the moment, and that's what we're really aiming for. Sorry, yeah.
You mentioned that your app is processing PCR data.
Yep.
Have you gone through the obtaining the record of compliance for the Kubernetes platform?
Not yet.
Have you had the chance to think about how to secure your platform in regard to the access management?
So we had a planning meeting about that last week with our ops team, who unfortunately, so part of the rationale for this, we've got a big Rails monolith, and there was a whole stack of credit card processing code in that. We're pulling that out mainly because other people in our company need that code and it's currently contained in our thing. So it's like, okay, sensible thing, make a service, everyone can make use of it. That way only the PCI compliance is in that blob rather than scattered throughout like lots of view code and shit. And unfortunately, that is the first Kubernetes and Terraform system that they've gone, all right, we've got to do the PCI stuff now. Kubernetes makes some parts of it a little bit harder in some ways. Like if we just used AWS, in some ways it would be a little bit easier. We'd make up IAM roles for everything and just say, only you can talk to that database and conduct these operations. Kubernetes has all that, but it's different to AWS, and getting them to talk is the main challenge. So when we've solved that, and or we're not all in jail for breaking PCI compliance, then I'll report back.
Another question I had, you mentioned that your ops did some comparison between different products. Have you had a chance to look at the DCOS and comparing with Kubernetes? Because I know that DCOS now is taking action to obtain more compliance certificate.
Well, that's interesting.
Default compliance, they got I think PCI 1 or something in the last year.
Cool.
I'm not sure whether you had a chance to look at that.
No. I will talk to them about it. That sounds very interesting. DCOS? Okay.
It's kind of a variation of the Apache Mesos.
Okay. I will have a look at it.
That's Apache, isn't it?
Sorry?
Apache.
Yeah, it's running on other places.
Okay. I'll mention it once again. Once again, it's like an area which is like.
The area that I really like to know more is about the PCI part data, because I faced this challenge before in my past.
Well, we definitely will have to deal with some of these details because we're in the hotel industry, and there's some horrific things that people in the hotel industry does. Hotel talking to the customer says, "Oh, okay, give me your CVV," and they write it down on a piece of paper and they type it into the database, and all of the things that you're not supposed to do. But and we have to sort of guide them towards the right way of doing things, but also sometimes we just can't as well. Yep. Cool. Any other? Yes.
How do you manage your deployments to different environments, or the configuration? Do you have different configurations for different environments?
You're talking about difference between our test environments and our production environments. Yeah. So the way we have it at the moment is it's a nightmare. The way it's going to be in the future, in a bright, squeaky clean future, is everything should be roughly the same except for the destination it gets pushed to in the PR, in the, which branch, and that should ideally trigger off a BuildKite script which loads the right set of configured variables and loads where it's got to go to and makes those changes there. The big problem we've had, and the only reason that's stopping us doing that at the moment is that our servers all out on AWS, each one of them have been treated like a special snowflake, and someone's come rushing in and gone, this has to be fixed right now, and somebody stays up till midnight and they type furiously on their keyboard on their command line, and it gets configured and it never gets documented and nobody knows about it, and that server is now left in a state that's no one knows, and so on and so on and so on. And the process that our ops team are really driving with us as well, and it's quite good because it's not really an us and them thing, it's our ops team are working really close with us, because they want everything to be scripted and replicable. So there's no special snowflake servers, there's an automation script for every single one of them, and everyone knows how to use that automation script to get it in the state that it needs to be.
I was just going to say, we basically have a very similar setup to that, and that build, when you trigger it to build that original build mass staging, and then to get it to production, you use that exact same baked image, and you just update the deployment, the Kubernetes config in the deployment, which is one of the YAML parts, with the new build number on the end of the image, and it just deploys that exact same image.
Have you heard of Helm?
Of which one?
Helm.
Yeah, so yeah, that's yet another thing that my ops team told me, oh, you need to use Helm for that. I don't even know what it does, but something like that, I think.
I think you'll end up using Helm when you manage your repositories.
I was given a nice example of something that I could do just by typing, about 20 lines of stuff, or you could do 1 line of Helm, and I'm like, yeah, I'll do the 1 line of Helm. That sounds great.
Yeah, because I was the way you are a month ago.
Yeah, right.
And then when we started using Helm, they were like a lot easier.
I like the sound of that. It sounds great. Yo.
So it seems like you get inherent value in things like Terraform Kubernetes with their abstraction layer over their provider that you're using under the hood.
Yeah.
But it's, in my experience, not very clean. You still have to say you want an EC2 instance. You can't say you want a generic piece of thing.
That's what Terraform is. Terraform will have stuff. So,
Yeah, correct. But you still have to say you want an AWS thing or Google Cloud thing. So I was wondering, the question was I have is, how do you integrate this? Is your plan to be across cloud or just prevent too much coupling with AWS?
So we're not really a provider. We just build stuff that we on-sell to our clients. So for a niche market. So although we're intellectually interested in being compatible with other cloud providers, we don't really care. If there was someone that was cheaper than AWS, we'd probably consider it. Yeah, possibly. Google Cloud, I've used Google Cloud once before. It's good. I don't know. Yeah, I hear what you're saying. I kind of wish something like that existed for me, outside of work. So I was I could just go, give me some services. And kind of Heroku already does that, so I don't care.
Is abstracting the cloud what people really want? Isn't it
They provide you
one version of that mythical?
No, I don't think people
need
need
to go to
abstracting the cloud.
databases.
It's about getting your deployments made easier. It's not
Yeah.
about I want to go to 5 different
Oh, right.
providers.
Yeah, but what I mean is the problem of I'm not saying don't use Terraform or any of these, but people really care about the ability to go, I want to get off AWS, go to Google Cloud without checking.
Large organizations do care about that. That's what cloud foundries business model is baked into that idea of being able to deploy to multiple different cloud environments. So there are large companies that really care about that and buy into that idea of being important to them.
I can.
Provide nice tools that can be version controlled. So they make a lot of sense.
No, I get the value of the automation and stuff, but I just was wondering if the abstraction was actually something itself, the abstraction of the particular cloud you're on.
I think that's very contingent on your business model. So, for example, at Digivisor, we had a large compute requirement, which was constant. So something like Hetzner was ideal for that. It's ridiculously cheap and works very well. But then you might want to monitor fluctuation or to deal with fluctuations for other things. So being able to combine, AWS is expensive. And if you're not a company or you're a startup, it's quite prohibitive.
Yeah.
So if you have different requirements, then it can really, really help. And something like Terraform, Kubernetes, all those will really help.
But I think your point is probably the opposite of that in some ways, in that AWS is expensive, but it's mostly expensive because it's really easy to configure a whole stack of shit that isn't even being utilized properly.
See, as a counterpoint to that, I used AWS probably 8 years ago. I haven't used it since.
Yeah.
And I have no idea. I'm flapping around all over.
Yeah.
And that's familiarity rather than it being easy.
And so is most people, right? It's just big and confusing. So, yeah.
Big and confusing is.
Yeah. Cool. Thanks, guys.